So in this demo, we're going to talk about the Stirling engine. This is a good example of different thermodynamic processes acting on a material. In this case, the material is simply air. With a temperature gradient, work can be extracted. Now, here is a Stirling engine, and the working fluid inside is the air inside of this container. And what I'm going to do is I'm going to put the Stirling engine on top of a cup of hot water. And now, what's happening is that the steam from the water is touching the bottom of this container. So we have the bottom side that's getting hot, while the top side stays at roughly room temperature. So the bottom side's getting close to 100 degrees Celsius, whereas the top side is room temperature, which is about 25 degrees Celsius. That's a temperature difference of 75 degrees Celsius. So let's see if it's gotten hot enough, and I'm going to give it a little start. And you can see that it keeps going. This is an engine that's turning heat, or really I should say a temperature difference, into mechanical motion. Now, what if we wanted this engine to go faster? What would we do? Well, one thing we could do is we could make the hot part hotter, because again, it's all about how big of a difference in temperature we have. But in this case, this Stirling engine would actually, some of the parts inside would start to break if I got the hot part above 100 degrees Celsius. So instead, I can make it go faster by making the cold side colder. Let's take a look at what happens when I put a little bit of ice on top of the engine. Okay. Notice that with just a little bit of ice on top, it's actually spinning a lot faster. So I made it colder and I got more work out of it. Why? Because I just made one side colder. And so the temperature difference is closer to 100 degrees Celsius, since ice is 0 degrees Celsius, than 75 degrees Celsius. So I've increased the temperature difference. And that's what matters in terms of how much work I can get out of a heat engine. Now, the Stirling engine is an example of a thermodynamic cycle, where the pressure and volume and temperature are all changing in the phase diagram. There are different ways to do this, though, in order to extract work, mechanical work, from heat. There are many different kinds of thermodynamic cycles that can be used to do that. So